Ignition sequence starts.
Good morning. This is the view inside the International Space Station Flight Control Room at NASA's Johnson Space Center, where there's always a team of specialists on duty monitoring the health of the station's systems and working with the crew members as they progress through a daily agenda of science support and station maintenance. This week, that agenda for Commander Sergei Ryzhikov and his Expedition 64 crewmates has included capturing, berthing, and unloading a new supply ship while getting ready for the fourth spacewalk of this increment coming up this weekend.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, a cargo resupply vehicle arrived to the space station, and astronauts prepare to venture outside the hatch into the vacuum of space for a spacewalk. On Monday, Northrop Grumman's CRS-15 cargo resupply vehicle, named the SS Katherine Johnson, in honor of the legendary NASA mathematician, arrived to the space station carrying over 4 tons of science investigations, cargo, and crew supplies. CRS-15 launched from the Wallops Flight Facility in Wallops, Virginia on Saturday, February 20th, and was captured with the station's robotic arm by JAXA astronaut Soichi Noguchi, and then installed to the station's Earth-facing side of the Unity module, where it will remain until late May. Science investigations on board this Cygnus include Micro 16, which is an investigation studying muscle strength changes in worms to help us better understand muscle weakening that astronauts can experience in microgravity. Lam Davison's second experiment headed to the space station to study the advantages of manufacturing artificial retinas in space. And AHOS, a radiation detection system developed for the Orion spacecraft and certified for use on NASA's Artemis II mission, the first Artemis mission on which a crew of astronauts will orbit the moon in the spacecraft. On Sunday, February 28th, 2 spacewalkers will begin work for upcoming solar array upgrades. NASA astronauts Kate Rubins and Victor Glover will work together to begin assembling and installing modification kits required for solar array upgrades during Sunday's spacewalk. Though they are functioning well, the current set of solar arrays are showing signs of degradation, which was expected. 6 new solar arrays are scheduled for delivery to the station during 3 resupply missions starting later this year. Each new array will produce more than 20 kilowatts of electricity. You can tune in to watch the spacewalk, the third for both Rubins and Glover, on NASA TV and the agency's website. Live coverage will begin at 4:30 a.m. Eastern. That's Space to Ground for this week. Thanks for watching. As always, keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The International Space Station is a laboratory in space where scientists can remove the constant of gravity from an equation in ways they just can't do on Earth. It's a trick that can be especially useful in natural sciences. For instance, researchers are working to learn how surface tension and capillary flow can be harnessed to improve systems for moving fluids in microgravity, like moving propellants in fuel tanks during space travel. For future missions, like when we go back to the moon and then out into the solar system, biomining could offer a way for crews to obtain needed materials on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do here, and that might affect the output from extraterrestrial biomining. So, there's an investigation on the International Space Station studying how microbes grow on and how they alter planetary rocks in microgravity and in simulated Martian gravity.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
The International Space Station serves as a one-of-a-kind platform for scientific research, taking advantage of the microgravity conditions to perform experiments that just couldn't be done here on Earth. Now, that includes experiments in an atomic refrigerator, which is capable of cooling matter down to just above the point where, in theory, the thermal activity of the atoms comes to a stop.
Cool Science on the International Space Station. Presented by Science at NASA. NASA researchers are creating a spot colder than the vacuum of space inside the International Space Station. It's called the Cold Atom Lab, or CAL, and it can refrigerate matter to 1/10 billionth of a degree above absolute zero, just above the point where all the thermal activity of atoms theoretically stops. At this temperature, atoms lose their energy and start to move very slowly, explains Rob Thompson, CAL project scientist at NASA's Jet Propulsion Laboratory, or JPL. At room temperature, atoms bounce off each other in all directions at a few hundred meters per second. But in CAL, they'll slow down a millionfold and condense into unique states of quantum matter. CAL is a multi-user facility that supports many investigators studying a broad range of topics. Eric Cornell, a physicist at the University of Colorado and the National Institute of Standards and Technology, will be leading one of the first CAL experiments. Cornell and his team will use CAL to investigate particle collisions and how particles interact with one another. Ultra-cold gases produced by the Cold Atom Lab can contain molecules with 3 atoms each, but which are 1,000 times bigger than a typical molecule. This results in a low-density, fluffy molecule that quickly falls apart unless it is kept extremely cold. How is particle behavior affected as more particles are introduced? What can be learned about quantum objects when several atoms are interacting at the same time? Cornell says the way atoms behave in this state gets very complex, surprising, and counterintuitive, and that's why we're doing this. Cornell shared the 2001 Nobel Prize in Physics for creating Bose-Einstein condensates, another state of quantum matter that can be studied inside CAL. Bose-Einstein condensates are essentially blobs of quantum matter that look and behave like waves that exist at these ultra-cold temperatures. In the free fall of space, the condensates can hold their wave-like forms for 5 to 10 seconds, much longer than on Earth, providing researchers a window into the quantum realm. Thompson says we can use CAL to test general relativity and quantum mechanics. One of the biggest questions in physics today is how those two work together. University of Rochester physicist Nick Bigelow and University of Berkeley scientist Holger Mueller, along with their colleagues, plan to use CAL to test a cornerstone of Einstein's theory of relativity, the equivalence principle, which holds that gravity and external acceleration cannot be distinguished experimentally. They plan to repeat Galileo's iconic experiment dropping cannonballs off the Leaning Tower of Pisa, but using atoms instead. Dropping atoms inside CAL and letting them fall for several seconds as the station orbits Earth will allow researchers to precisely figure out the differences between how the atoms accelerate. This experiment may reveal how gravity and spacetime are woven through the quantum realm. A researcher at JPL named Jason Williams also plans to use ultra-cold 2-atom molecules to develop tools for the next generation of precision gravity tests with quantum gases. Many more experiments are planned for this cool new laboratory, and no one knows where they will lead. With CAL, says Thompson, we're entering the unknown. For more from the International Space Station, visit www.nasa.gov/station. For cutting-edge physics on and around Earth, stay tuned to science.nasa.gov.
Flight engineer Kate Rubins is both a scientist and a NASA astronaut, and there's no better place to be for someone with those two job titles than aboard the International Space Station. Rubins says being free from Earth's gravity makes this outpost the perfect place to conduct research.
The reason that you would do any kind of experiment in space is if there's something particular about the space environment, and most often that is microgravity. So mostly the ISS gives us the ability to either do something that we can't do in a facility on Earth or investigate some phenomenon, some property in a way that we can't on Earth. So for example, some of the tissue architecture, these really delicate tissues, as you start to build them up, they would collapse because you have gravity, or the cells would naturally settle to the bottom of the plate. And so you just can't study the answer to the question that you're looking for. So the space station lets us have that ability to either test what the effect of gravity is or remove that problem entirely from our experimental setup. Yeah, the space station's an incredible place to conduct research. It was sort of like being in the world's most amazing lab when I was up there in 2016. So when you're a scientist, you're used to working on one thing over and over and maybe really refining the details on that over the course of a PhD thesis or a lab project. On Space Station, you get somebody's incredibly refined project times 200 different fields. So for me, it was a chance to learn about all these different areas of science, and they each have a team behind them. So I was usually pretty excited to open the container and do whatever experiment that day brought. I also really got a chance to talk to those PIs, the principal investigators, and those scientific teams, and understand everything that was going on behind their experiments and read their papers. So by the time I got to doing the experiment, I was pretty excited to take it out and to see what was going to change in microgravity. Yeah, science in space, it's an amazing lab and it's incredibly fun. So we are smiling all the time. I'm Kate Rubins. I'm a scientist and an astronaut.
When you look up at the night sky, you notice the moon appears to change shape from night to night. Those different shapes that we see at different times of the month are called the moon's phases. In this demonstration video, NASA astronaut Anne McClain and a friend with an Earth-shaped head explain why the phases of the moon occur as they do.
Hi there. My name is Anne McLean, and I'm an astronaut who has lived and worked 250 miles above the Earth's surface on the International Space Station. Today we're going to be turning our eyes toward the moon and learning more about what causes the moon phases. But before we check out the moon phases, let's take a look at where the space station is compared to where we are on Earth and where the moon and the sun are. On Earth, you're only about 250 miles below the station. The moon, however, is located 238,855 miles on average from Earth. You could fit 30 Earths in that distance. When you think about how far away we are from you on the station versus how far away the moon is, the station is only a tiny bit closer to the moon than we are here on Earth. And that's only when the station is in orbit on the same side of Earth as the moon. So, the station is 250 miles away, the moon is 238,855 miles away, and the sun is approximately 92,900,000 miles away. That is quite the distance. Now that you know where you are relative to the station, moon, and the sun, let's talk about the moon phases. Now, when you're looking up at the moon from the Earth, you'll notice that it looks different from day to day. We call these differences the phases of the moon, and they cycle through every 30 days. Let's check out a demonstration of the moon phases here on the ground. We're going to pretend his head is Earth, letting him view the moon as you would from your home. The ball in their hand is going to represent the moon, and the light source is going to be our sun. Keep in mind that while the moon is orbiting Earth, Earth is also rotating on its axis and slowly orbiting the sun. Now, looking from our outsider perspective, we can see the moon is still whole the entire time it is orbiting around Earth, with the side facing the sun always illuminated and reflecting sunlight. Let's take a look at what he is seeing. As you can see in the photographs from Earth's view, the reflection of sunlight looks quite different from this angle, since we are only able to see parts of the reflected sunlight as the moon moves around Earth. This is what causes our moon phases, as the moon orbits around Earth every 30 days. There are names for each of the phases of the moon's 30-day cycle. When the moon looks completely dark, we're experiencing a new moon. This is the beginning of the 30-day cycle. It will move through a waxing crescent phase until it is a first quarter moon. From here, we will see a waxing gibbous until the moon appears fully illuminated. You might have heard this phase before. This is what we call a full moon. After this phase, the moon will go from a waning gibbous phase into a third quarter moon. After the third quarter moon, it will become a waning crescent until it returns to a new moon. On the space station, we see the same moon phases as we do on the Earth's surface. Since the space station is only 250 miles closer to the moon than we are here on the ground, astronauts on the station have the same perspective you have, but don't have the Earth's atmosphere in their way for photographs. Astronauts currently on the space station actually use the moon's phases to collect research that will help NASA with the Artemis program as we work to go forward to the moon with our astronauts by 2024. So, the next time you're outside, take a glance up at the moon to check out what phase it's in. Are you interested in seeing the space station fly by as well? Ask an adult to help you sign up for Spot the Station at spotthestation.nasa.gov. Thanks for learning with me today. See you next time.
One important aspect of the missions of the International Space Station is to teach humankind what we need to know to be able to explore farther away from Earth in the years to come. That knowledge is fueling the Artemis program and its efforts to return astronauts to the moon in a few short years. There's great progress being made all over the country in getting the hardware ready. Here's an update. The fact that most of the members of the Expedition 64 crew have been to the space station before doesn't mean that they don't still get a thrill when they look down on the panoramic view of Earth. Former station crew member T.J. Creamer, who is now a space station flight director, has a few thoughts about the impact of his first views of the natural wonders of Earth from 250 miles up.
And liftoff.
10 seconds.
I think what you get a sense of is just how awesome the universe is and how tiny each of us are in the grand scheme of the wonder that exists out there. Realizing that and realizing just how overwhelmingly huge the Earth is, how overwhelmingly the physics dominates what we're doing, and that we're living in this solar system, galaxy, universe, lets you know that this is someplace kind of special. To be a part of the mission that serves on station, to be part of the mission that goes exploring space into this vastness is simply, one, an honor, but two, almost mind-changing. Mind-changing because we have businesses, we have missions here, we're focused on accomplishing the near-term goal. You get up there and you see the overwhelming portion of the Earth, the vastness that you're exploring into, and you go, wow, there is just so many questions, so much for us to do, so much for us to be able to help our brothers and sisters with. We had a special opportunity on space station because of the window arrangements to be able to seriously get immersed in the imagery. Going to the windows to watch areas that were of great interest. Patagonia, for instance, is just a beautiful, rich environment of earth tones as well as the glaciers, the water. It is just picturesque to the point where you go, I need to go visit that place. You want to find things on the Earth because it is memorable, but also insightful. For instance, you're going over a tan and you go, oh, you know what, I bet you I'm close to the pyramids. And so you go to the window to take a look at if you are close to the pyramids, and then take some shots that you can take home. There are areas of the world that have volcanoes and you just happen to catch in one photograph 2 or 3 active volcanoes. It's a nice experience to be able to look out the window and go, wow, we really are seeing the living Earth living, and being able to be a part of it from such a vantage point. We saw Hades troubles while we were up there. The Gulf oil spill from the horizon occurred while we were up there. A number of hurricanes or tropical cyclones occurred while we were up there. You know there's a ton of energy in there. You know it's heading towards populated areas. It's not beautiful at that point. It's utter respect is what I would categorize it. I got visited by 3 space shuttles. Several of the crew members never looked outside the cupola before. I would bring them one at a time to the cupola. Tell them to close their eyes, open up all the windows, the shutters on the windows, and then tell them to open up their eyes. And that instant, when you're overwhelmed with that vista, when your eyes see nothing but the beauty of the Earth, every single one of them, every single crew member that I brought in there for that exposure cried. It is heart-stopping, it is soul-pounding, it is breathtaking.
If you want another look at any of the stories we featured today, you can always find them on YouTube and Facebook, where you will also find lots of other great features on a wide variety of NASA topics. Be sure to look around. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, we bring you the first of 6 panel discussions on the history of the International Space Station. kicking off the series with a talk with the members of Expedition 1, the men who kicked off the permanent human presence in space in late 2000. Go to nasa.gov/podcasts for this week's episode and all of our previous episodes. In fact, that's where you'll find the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.